And of course, we didn't like stay together forever. You know, when I went to college, we like took a split for a little bit, just to, like, you know, she was still finishing up her senior year. Actually, she was in post-secondary, so she was going to high school and college at the same time.
Oh, so she was smart.
Yeah, she's smarter than me. She's way smarter than me. But so, yeah, I've known Veronica since she was, I think, 12. Yeah, we did the math. It was 12.
That's younger than me.
I know, which makes sense why I teach middle schoolers. And just, it's younger than all of us? Whoa, let's stop divulging personal information. Since I just hit, like, we're recording now because we have math to do. What's your social security number? What's your... No.
2, 5...
You probably don't even know your social security
I don't
number.
even know how many digits the social security number has.
Like, the number 5? You have to be real old for your social to be that short. My social is 9 digits long. Your guys's are either 9 digits long or 10 digits
Oh, did
long,
they just
probably.
get bigger?
Yeah, I mean, I don't think they're ever going to recycle a social.
They're still with a 0 or a 1?
Well, presumably. Can I help you? So, grab those resource pages. You look lost. She looked lost and she ran away.
Really? Mine is pi.
That is hilarious.
Well, they were talking about scheduling stuff, so I just listened.
We can. All right, so what we're...
Sorry, I have a question about from yesterday.
Okay.
Are they getting rid of EPP?
That's a complicated answer. So, how people EPP is changing.
How?
You're welcome. You can have a lot. I got a bag full of them. So.
How does one EPP?
So, CPM has different compression routes that, like, districts can choose. The route that we had chosen was based off our middle schools being 7th and 8th grade. Now that our middle schools are 6th, 7th, and 8th grade, we are starting the compression at 6th grade. So, students who are on, like, the EPP track or whatever you want to call it.
We started in like 3rd grade.
Okay, that's different. Because you are identified, gifted, and served based off your gifted identification and therefore are grade level accelerated. We are talking about just, oh, hey, you're pretty good at math. Do you want to, like, take a challenging class? That's different than identified, gifted, and served, right? So there are different, like...
But like how our EPP works is they compress like 3rd and 4th grade.
And here's what's wrong with what used to happen. That was at your elementary school. It wasn't the same across the entire district. Different schools did different things. EPP at one school might have meant...
It's the same between my 2 schools.
Yeah, so EPP at one school might mean your grade level accelerated. EPP at another school might mean you do extra projects and the class is a bit harder, but you're just still learning the same math that you would have been. So we're trying to make it all the same across the district. Students who are still a grade level accelerated, that still happens. But if you didn't get identified, like back in the 3rd or 4th grade, and you just realize I'm good at math, now, starting in 6th grade, you can take accelerated 6-7, and then in 7th grade, you take accelerated 7-8, and by the end of those 2 years, you've taken 3 math classes. So then you take Math 1 as an 8th grader.
So is that why there's a bunch of kids in Math 1?
Well, they did accelerated 7.
Yeah, they did excel. Yeah, what we call it compressed to really get the idea of it is compressed. It's not EPP. It's not like more in depth. It is literally squeeze it together, take out all the frill, just teach what you got to teach. And it's not a good idea to take 2 classes in 1 year. That's harder than to do 3 classes spread across 2 years.
Yeah.
You know what I mean? You guys can math. You know how this works.
Yeah.
Did you basic
I worked at
division?
elementary schools that I went to was like...
So it's still changing.
We
It is.
did like 3rd grade and half of 4th grade, and then the next year we did 4th grade and all of 5th, and the rest of 4th grade and all of
And that gets really confusing for parents. Of like, wait, what grade they're in versus what grade they're taking. So, now how it should work after this year is students who come to Phoenix they're 7th grade, right? So if they've taken accelerated 6-7, they'll take accelerated 7-8. If they were already in Math 7, they'll take Math 8, right? If they're like a year accelerated. Or if they're a regular math track, they're a regular math track, right?
But for Math 2, have you decided if
we have to figure out the schedule first. So it's still kind of up in the air. They're going to pull the lottery next week, and then we'll know numbers, and then we'll be able to go from there. We always want to keep kids here, right? It involves kids who currently take Math 1 with Mr. Hall, Duresh and Dianesh, right? So I don't want them to have to go to the high school, just like I don't want you guys to have to go to the high school. It's wasted time on the bus.
Well, oh, you mean this year? Okay, I thought you were like, you don't want us to go to high school?
I mean,
You gonna fail?
I'm sure at this point you're ready to move on from this place, but maybe not. I don't
I'm
know.
excited for
Well, I'm
this.
trying to
It
live
feels
where
like
we
a
just-
lot more opportunity.
Which I've been told is basically just old people.
What?
Like, it's like the
That's the fourth time today I've heard a kid say old people, and it's starting to resonate harder and harder with me.
Mr. Hudson, you're
Oh,
only like
it's like
30.
4 years of Phoenix.
No.
You're close. You're only off by 2 years.
You're 28.
I wish.
Oh, okay. You're 35.
Wait, I just said you can math, and now I feel like maybe I need to take that back. All right, so when we're talking about functions, what you're going to start to see is situations where we have to combine the functions with each other in order to create a new function that involves both of them. So I promise you this relates back to real situations where you would model something and then like intercept with another thing, and now the functions are happening together and they impact each other. So there's a brand new function, but as we start to learn it, we're going to use some of the more basic functions that we've visited previously as to not overcomplicate it. So if we call c of x just 3, what does that function look like?
It's just a straight line.
Horizontal, vertical? Horizontal, right? Because a vertical line is not a function.
Oh, yeah.
So f of x being x squared is what kind of function?
Exponential.
Parabola.
Oh, yeah.
Because if it was 2 to the x, then that would be exponential. And g of x, 2x plus 1, is linear. So on our handout here, we have a column for, notice we don't have c of x and g of x on here. We just have f of x being x squared. I bet you can fill in the x squared column pretty quickly. So before you try to whiz through this entire worksheet, like the rest of the columns, we will in a moment. But we got to practice this and make sure that we know what we're doing. So if we tried to combine the functions through addition, f of x and c of x,
X squared plus 3. Right?
Yep.
do we all agree?
Maybe? I'm just guessing.
So x squared was my f of x, and then plus 3.
Yeah.
You okay?
Yeah, because like substitution, if you think of it like a variable.
So then b of x being c of x times f of x, we're composing functions.
Yeah, 3x squared.
Well, right now we're combining functions, but then we will eventually compose them with each other.
And talk about things I haven't done in a minute. That's the problem right there.
So what I'm alluding there then are situations where we do f of g of x,
What?
and that we'll get there. That's beyond what we're doing right now. Right now we're just combining them using the regular operations. So what do we think? C of x times f of x would then be, yeah, 3x squared, right? You're multiplying, that's an eraser. 3x squared. So you guys ever notice Estes and Kabila like to just drop into the math class? I think they miss math. Like,
It's 2x.
well, and Kabila used to teach science, right? Like, well, not even just here, but at,
Like the science.
no, he used to be a high school science teacher, Mr. Kabila did. And yeah, Mr. Estes used to teach at McCord. G of x minus c of x, careful, now we're using g of x.
2x minus 2.
Yeah, 2x negative 2x, it'd be 2x plus 1 minus 3, so 2x minus 2. Okay, and c of x times g of x?
It's just 6x plus 3.
Ooh, 6x plus 3, make sure we distribute that, right? Alright, that felt a little bit too
Wait.
easy.
Oh, with C of X. I thought we were trying to do G of X.
You actual silly person.
So, feeling good on that? Let's make it harder then.
Let's make it harder.
So h of x is 1/2 x plus 1. Still what type of function?
Linda.
Linear. Linear. So If we look at the resource page and start combining these functions with each other for a domain of -3 to 3, I want to give you guys a few minutes to just mess with this and compare with each other. And if you guys all agree, you're probably right. So we are now on the resource page. We are now going to combine. I keep wanting to say compose, but we're not there yet. Are you justifying this to yourself? Or?
We don't talk about how it took me till all the way until x equals 1 to figure that out. That I could just add 0.5 each time. We don't talk about that. Oh, you just add them together.
I can't imagine walking down that hallway as a 12-year-old.
Dude, I did that at McCord, and I was like a young. Wait, actually, was I 12-year-old? I was a 12-year-old.
It makes me anxious. Yeah, it makes me anxious even from here. Like, I would probably just wait. You know what I mean? I would, like, stay at lunch and just eat and walk last, probably.
And then you get expelled.
No, I would tell the teacher I didn't want to walk in the chaos of people.
And then the teacher would be like, too bad. Well, actually, depending on the teacher.
Yeah, depending on the teacher.
I don't know. I feel like Mr. Hall would be like, too bad.
Yeah,
Like,
depends.
when I went to go wrestling every day, I had to come up here and sign out, even though tardiness.
So I wonder how much Jake got filled in before he left. The whole table.
Mine is h of x.
So we'll have to double check.
He filled in the whole table.
Already?
So that means he did it when you were talking.
Yeah, my guess is he started on it while we were talking.
Now is the hard one. F of x times h of x. Oh, you can just multiply them together.
What's that going to turn into then? So that's the p of x, right?
Yeah. Actually, I don't know if you can just multiply them together. I'm going to do it. Actually, wait, you should be able to. Because substitution. Pause.
What do you mean because substitution?
Wait, that's 1 times 0 is not in fact 1.
So the f of x times h of x is up here. What do we think that's going to get when we multiply those together?
Like the equations?
Yeah, what is p of x? What is that new function?
P of x would be 1/2 x to the third plus x squared, right?
Ooh, 1/2 x to the third plus x squared. Do we know if you think of x to the third just in your head and try to visualize,
Cubic x.
what does it look like?
It looks like that, and then it goes straight, and then it goes down.
Straight?
And then, I don't know.
Oh,
Well, be careful because if we're using math vocab, we want to use it accurately.
Like the shape, it's like
Yeah,
like a
that.
sideways S.
So kind of S-like.
Yeah.
S.
Now the question is, as we modify the pieces of it, how does, like, so you're saying it initially looks kind of
Actually,
that
it's
like?
the other way.
Yeah.
Ooh, I was about to ask. Or is it this But then this is obviously modified, right? Because we got a 1/2 there. We got an x squared added onto it. So go ahead and fill in your table values, but then we're going to look at like what do these things look like? Because you've got a couple graphs down at the bottom that we can sketch on.
Yeah, I do want to.
So the graph on the right is where we're going to put p of x. Okay, the graph on the left, you can put any of the other functions. Does that make sense?
So if we don't have room on it, we just not like place it
For which?
for P of X. I don't
You got room.
for the first one.
What do you mean?
Isn't it negative 4.5?
So you might not be able to get to -3, but you have room to then model everything else from -2, -1, 0, 1.
My
You
question
won't
was
be able to
it's
model
not-
2 as well. So 2 will be off, right? Because we only go up to 6. Do his answers agree? You double checking your math
He got 23.5.
for.
I got 22.5.
You're correct.
Great.
Whoa. I got 22.5. Wait, Jake got 43.5.
No! 23.
Oh,
Oh, and they're like Irish themed.
okay.
Well, now I'm jealous.
That's a more reasonable wrong.
Jake, we found a mistake on your paper.
L.
What did I
Did
do?
you just say the word L?
Yeah, L.
What did I do?
Wow, that was like from the 90s. I love that that's still a thing. It's on a Smash Mouth song with the shape of an L on her forehead.
Yeah, dude.
In P of X, Jake, your input of +3, double check your work. You are off slightly.
Should we do J of X or K of X on the other one?
Yes.
Okay.
Because that will also help us look at like, well, how do they differ from each other? So I think most of us have our table values filled in. So to confirm that your table values are correct, here you go.
So on the left side is P of X?
On the right side, we only, well, I mean, it doesn't really matter as long as one of those graphs is to represent P of X, and the other one we can put the other
Dude,
functions.
this is the weirdest looking. Is this just a parabola? Because it looks weird about it, but I think it might just be a parabola.
Which one?
That's not right.
J of X.
Because 9
Oh,
times
Oh, I'm silly.
2.5
I'm silly.
is not 23.5.
Yeah, I'm silly.
So if we try to approximate how this is going to continue, could we extend it knowing what the next value is and relatively
Yeah,
where
but that's
that
all
might
the
be?
way at wait, where is that? Is that 8? So it's like up here. You want me to like put a point up here and then connect it?
At least try to sketch so that we show the whole graph so it feels continuous, right? It doesn't have to be perfect, but we want to try to show what we can. So now we're putting them on the graphs. I saw that you had a little bit back here. So what you missed me saying is that one of these should be for P of X because it has its own unique behavior. As we put up on the screen that is now covered up, it's a cubic graph, right? So when we combine those and look at what cubic graphs look like, so it's okay if you don't erase one of those, but we do want to model P of X on one of those.
Oh, it is. Okay, so the one is exponential.
So Jake, here's what we were asking is does it look like this coming down from the left or is it like coming down from the right and or like really is the graph like increasing or decreasing before we mess with it? And then as we mess with it, what happens?
When we mess with it, it gets like curvier in the middle part.
That's what happens as you get older.
Okay.
You get curvier in the middle.
You gain weight, you get curvier.
I didn't. Okay.
Kind of.
I'm just making the joke that I have gained weight. Sorry if it
You
fell
don't
flat.
look
Most
like
of my
you
jokes
gained
fall flat.
weight.
I should probably lose a little bit of weight.
No, I might be slightly biased given.
You've
Which
only
graph
really
do you
known
put
me.
on the other side, other than P of X?
actually doing J of X?
Mm-hmm.
So we're just screwing action over.
Hey, you guys can all do all of them.
Well,
Like,
but
that's
then
allowed.
I don't have a third graph.
You can put all the parabolas on the same graph.
I have a piece of graph paper here, but I don't want to like draw the axe.
The effort threshold for using that piece of graph paper is just so it's passing that threshold is, man.
Yeah. Exactly. You get it. You get it.
So as I walk down, it seems like most of us, and I feel
Wait,
like
didn't
Jake
actually
probably.
see this.
Oh, for checking your answers.
Yeah. 9, 4, 1.
My bet is if you guys agreed, your answers are all correct.
Oh, we didn't check.
Because this is the only one that we disagreed on, the 22.5 over here.
Well,
I mean, especially when we have to go to the restroom. Sometimes that impacts our thinking.
Mhm. Oh, I thought. Yeah.
Any questions on any of the values in the table?
Give me 1 second. No.
One of the only times somebody has said 1 second and literally only used 1 second.
Yeah.
I don't really understand J of X.
J of X?
JMX.
How we got these output values, or
Why the parabola is like different on each side of 0.
It's not. It's just you don't see the vertex because the vertex isn't in a nice location.
what do you mean? Nice location,
Like
say
it's
more.
not like on a value of 1. It's like.
Or like a value of 0, which is the nicest.
Yeah.
So,
I mean, it's not. It's not like at like. It's not like at a 1. It's not at nice axes.
so you mean you end up with some parabolas that look like that?
Yeah. Ugly. Ugly problem.
So J of X, which was f of x plus h of x, seems like the vertex would be on the left side of the y-axis. F of x, which is our standard parent function of the parabola, just x squared, that is nicely centered. So that one is nice. And then k of x seems to be off to the right. So, and then they all cross right here. They have like a commensurate point.
But then they spread out on the other side.
Yeah, but then they're, well, are these spreading out or are they ever going to come together?
Maybe actually.
Depends on their steepnesses, right? So we would need to follow that behavior out a little bit to determine.
Weird that they don't all have the same steepness. Actually, no, it's not that. Can't imagine.
So, are we all cool with these graphs? Can we what?
Oh, I put P of X on the. I put it on the wrong side.
So, this is based off our table, right? But if we go and we like use some Desmos to help us look at this stuff, anyone have predictions on like, so this obviously is not,
Could you put like X squared up there too? Just so we have like a.
ooh, like a comparison. I like it. Okay, there's x squared. Do you want to put in the other ones in Desmos? Okay.
Could you put the like linear one?
Which, so like 1/2 x plus 1?
Yeah. Because those are really the two that it's using. Yeah, I don't see much correlation between them.
So what if I copy this?
Wait, actually, P and 1/2 x plus 1, they intersect at like the same point for their x intercept. Like, no, like their x intercept. Like at -2. They both intersect at -2.
Ah. Interesting. What would happen if I get rid of this 1/2? Because really, if I get rid of it, we turn it into a 1.
It gets bigger. Or small. It gets smaller.
So the 1/2, the coefficient to our x cubed,
Multiplies it by 2. Like, it squeezes it out. Wait, but only
happens to a negative number when we cube it?
It becomes negative.
Yeah.
What happens to a negative number when we square it?
Positive.
It becomes positive.
Wait a sec.
It's
Oh.
like two parabolas.
So, but they're the x squared. For that little bit on the left side, the x squared overrides the x cubed.
Ah, you're jumping over what I was about to show us. Is so if we just look at x cubed,
X to the half.
that would be yeah, we don't want to go down that route of more symbols involved. So that's why 0, it's not really like our vertex, right? But it is the nice point where if I input 0, 0 cubed is 0, then any positive number cubed gets a positive number. Any negative number cubed gets a negative number. But then adding a coefficient onto here, like let's say 2, or 3,
You make the angle
Or
sharper
4.
because the numbers are going up and down quicker.
Oh, because this is making the numbers grow more quickly because that coefficient is going to just make them larger numbers, right? Unless that coefficient is less than 1, right?
One greater than negative 1.
Yeah, ooh, wait, what about negative
They'll
coefficients?
probably like flip it side to side.
So actually, I'm going to leave x cubed there. What are some things that we want to test?
Negative x cubed.
Negative x cubed.
It does flip it.
And this is how we can quickly start to model, like, oh, now it looks like kind of like a bent x thing.
But they kind of look like
Right? They're not parabolas. This behavior is not parabolic, but the two graphs together kind of look parabolic. And it's not parabolic because
Is it exponential?
x squared.
Whoa.
So, let's get some clarity on exponential functions. A lot of functions look exponential, but what has to happen for the function to truly be an exponential? It uses the input in the power. So, comparing to an exponential, if we put the input in the power, right, the exponential, there's a certain section of the curve that looks pretty similar, but that does not mean that we should say, oh, it looks exponential. Like, be careful saying that, because a lot of things may look exponential. It's only if the input is in the power. So wait, so what did the adding x squared do? Let's turn this off and turn this off to get...
It gave it like a little curve to it.
It shifted it to the left.
Gave it some curves.
Shifted it to the left. Let me turn this off to...
Yeah, kind of.
No, it just shifted.
But it kept its base at like the same point.
So it still
It's not like-
does...
It kind of just shifted like. Well, no, because it also shifted that part to the left.
If I want to pull this up, any ideas on how to do that?
Make it a higher x squared value, maybe like 30x squared. Nope.
Oh. And that was only 7.
Make it like 2. That pulled it up. Oh, because
Put it up and left, right? I'm going to copy
well,
this.
If you look at like the right side, it barely moved.
So you said make that like 2.
Yeah. Look. Well, I guess it moved a bit.
Yeah, those,
They will intersect eventually.
the green and the purple.
Yeah.
It's gonna take you a while.
I said eventually. If you zoom out far enough, maybe you'll see the purple peek out from the other side.
By the way, if you haven't figured this out on Desmos, the home button takes you back to like a standard view.
Oh, nice.
So when you get yourself way far away, you can just click home and it takes you back. All right, wait. So a coefficient on just the x squared, we said can flip it. But what if we just make this like 7? Oh, so that squeeze. So a coefficient on x squared is like, what do we actually call that? Starts with a C. Compression, right? So that impacts the compression of the graph, which in a parabola it makes sense that we're compressing together. This, for x cubed, we have to think of it as compressing towards the y-axis. Right, at least if we're still in the parent form of x cubed, comparing to that parent form. So what if I add an x on here?
Do you guys remember on ST Math? I promise this is important. Do you guys remember on ST Math when there was like the data analytics stuff and like
Yeah.
the box plot?
Yeah.
And like they had a bunch of little boxes and it was skewed. It kind of skews to the left with the like x squared.
It's been a long time since I've seen that.
Dude,
Yeah, I didn't like that it didn't let me have any control. It would have you guys repeating the same activity over and over again without me being able to say, move on.
Move on, you got it.
Yeah, it didn't have teacher
Do
control.
they have ST Math for high school math too?
I do not believe so. I'm not sure, but I don't believe so.
Yeah, because high schoolers would realize, hey, this actually no, elementary schoolers realize it's not penguin.
All right, so quick challenge that we'll come back to then when we return on next Tuesday. So
PT was the subject of much hate at Evening Street.
Jacob notices that the advanced ski jump landing at his favorite ski park has been changed from a straight slanted slope to a curved hill. Sorry, I need to not try to look away and read. So he takes a picture of the jump and landing hill with his phone. We make a sketch on, of course, Desmos. So here we have the skier and then the ski jump, like the hill, right? Which is fairly poignant since the Olympics has been going
Like
on.
the skier's just gonna fall through the hill.
Or I don't know when the Winter Olympics start.
Oh no.
Yeah, I'm not sure either. You're right. I think that have Winter Olympics ended?
Yes.
Well, I don't watch TV. I really I turn on like Seinfeld when I go home and I grade papers.
I don't know. I like Summer Olympic sports better.
Yeah, that's happening in
So-
Bahrain.
It is time to go to lunch, but when we return next Tuesday, we are going to dive into this problem a little bit, but then also we're going to start talking about inverse functions.
Do we have assigned homework or are we just doing them?
If you really want me to pick questions, I can. I'll try to.
No.
Guys, this is the thing. Like, I'm on the same team as you. I don't want to make things harder for you. I just want to make sure we learn what we need to learn. All right. Critical problems. Really, I could just tell you which ones to skip if you want.
No, just tell me what ones to do.
If you're on the same team as us.
Don't give you any homework.
No, I was gonna say why didn't you hole punch this, and I realized I can just do it myself. So
Oh, and because I just printed it. Funny story though. The ones from yesterday were sitting next to the printer, which means somebody actually did just leave them there. We should do both 118 and 119. You can skip 120. Really, do the whole thing except for 120, 123, and 124. So skip 120, 123, 124. Sorry, I feel kind of like that's a bit easier to say. So you want to do 118, 119, 121, 122.
I feel like I already started one.
118, 119, 121, 122. So 18, 19, do them. 21, 22, do them. Make sense? There we go. Cool. Sweet. Well, guys, I'm assuming we're all mastered and having both discovery days. So,
You haven't really put anything on that.
yeah, I should have put like mastery for quarter 3, but nobody in 8th grade staff like bugged me about it. So you mastered math. So assuming you mastered everything else, good job. See you next Tuesday.
Yeah.
Bye, guys.